In the summer of 2003, just as my book was about to go to the printer, I discovered a technique that allowed me to take bowl components and reassemble them into a ribbon form. This led to a slight delay in my book publication in order to create a chapter 16. So in my book, chapter 16 talks about how to create a ribbon out of 3 bowls, 6 half bowls. In addition to the chapter in my book, this particular issue of American Woodturner, the summer issue of '07, it also has an article showing the different steps involved for creating a ribbon. So for this DVD, I've decided rather than do a simple ribbon, I'll do one a little more complex. I think you'll get more out of that. If you've never done a ribbon before, you may want to do a simple one first. But this one in front of me here, this is a piece called A Mighty Winds A-Blowing. It's sandblasted redwood, but it's built from bowl-turned components, quarter bowls and half bowls. It's been sandblasted. But I'm going to take this shape and create a ribbon in the same shape, but a much smaller design. I have a very good friend getting married in a few weeks, so this is a good opportunity to create a nice wedding gift. I'm going to create it with heavy edges, thick edges, and then a very thin center portion which I can pierce with some designs. So follow along. I'll go in the shop and we'll make a Mobius ribbon. This will be made out of 3½ bowls. It's actually, if you look closely, it's got a half bowl here at the bottom, it's got a half bowl at the top, and the rest of it's all quarter bowls. So let's get to work and we'll create a ribbon quite a bit smaller than this, but the same shape as this one. This particular shape requires 3½ bowls. It actually requires 2 half bowls and 10 quarter bowls. Each one of these 90-degree plumbing parts represents a quarter bowl. Where you see 2 of them in the same alignment, that would be a half bowl. To help keep track of all these components, I'm labeling the PVC pipe fittings. To get started on this project, I've selected a couple of boards of canary wood. I milled them to consistent thicknesses, put a jointed edge on one side, and now I'm cross-cutting them into about 3-inch lengths. I've chosen, this is my choice, to make each bowl about 5½ inches in diameter with 16 staves each. And I know for this ribbon to come around and meet back onto itself, the bowls will have to be constructed with a 45-degree slope angle. My first calculation will be to determine the wide end of the staves. This is a simple matter of taking the diameter times pi and then dividing that by 16. In this case, I need staves that are a little over 1 inch wide. But what about the compound miter angles? I need to know 2 things, the miter angle and the blade angle. The easiest way to determine those is to look it up in a chart. My book has a chart, but these charts exist in a lot of places. You go to the column for the number of staves, in this case 16, over to the slope, in this case 45, and look across and you'll come up with the 2 angles. The miter angle is a little confusing. That needs to be subtracted from 90 degrees in order to use it in a chop saw. So here's everything I need. My stave width, that's the big end, my miter angle, and my blade angle. I can go back to my chop saw and go to work. It requires a little trial and error to get the angles set just right, but I'll start off with both angles at about 8 degrees. I'm going to cut some test pieces from MDF, the same 3-inch dimension as my canary wood. I've put the angled cut, the compound mitered angled cut, on 2 different ends here. The piece on the left will be my permanent stop block. And with the clamps and so forth, I can cut one piece, flip, cut, flip, and I'll cut 8 pieces of this and then check my angles to see how close I am. If my miter angles are close to right, then I should be able to form a half bowl with these 8 staves. With some tape and the use of my joiner fence, this will tell me what's going on. In this case, I need to cut just a tiny bit less angle. Just a few taps on the side of my saw should do it. It wasn't off much. Now I'm testing the first 8 canary wood staves. They look very good. I'm also checking this angle, the 45. Now the project requires 4 bowls at 16 staves per bowl. Here's 64 staves. Making these kinds of cuts with a chop saw requires a good amount of downward pressure. Try to bring the blade down into the material as opposed to sideways into the material. Be aware that the front edge can be caught by that blade if this is done improperly. You don't want that to happen. I'm now pairing up my staves and I'm doing a close examination of each fit. If I find imperfect fits, I have the option of sanding them on my disc sander. By using pencil marks, I can get this table adjusted perfectly so the briefest of contact with the sandpaper erases the pencil marks. Then I can clean up any imperfections that exist on my good material. I now have 32 perfect glue seams ready for glue. There's lots of ways to glue staves like this together. A simple rub joint with no clamps would work. I prefer to put some pressure. This is just one way. Another way is rubber bands. That's another effective way at putting temporary pressure around a pair of staves in this shape. It's up to you whether you clamp or not, but it's been my experience that a clamp joint usually is a better looking seam. I've now consolidated 64 staves into 32 pairs. Now I'm pairing up my pairs into sections of 4. Inevitably, there'll be a little bit of glue that's contaminated these surfaces that needs to be cleaned up. And here are my next 16 seams ready for glue. I've found that the easiest way to perform this glue job is to use duct tape. By applying the tape in this manner, I create a need to stretch the tape when I close the assembly. When the glue joint is closed up, the tape will have to be stretched, therefore it acts as a clamp on the outside of the glue joint. These seams are now ready for glue. I suggest you try this dry a few times before you attempt it with glue. There's a delicate balance between the duct tape tension, the rubber band tension, and just the technique of getting the rubber band on there in the right position. A few tries dry will save you a lot of grief later on. Before putting these away to dry, make sure all your seams line up nice and flush with one another. So here are my 16 quarter bowls. I'm cleaning up the edges here, these seams. I want to be able to inspect those, make sure I don't have any defective joints, and I'm knocking off any glue contamination. Now I'm doing a dry fit of 4 quarters. I want to do any minor improvement at this point as opposed to waiting until I have halves. I've cleaned these up. I've paired them together. Here are my 8 halves ready to be glued together. Putting the quarters into halves is actually easier than the previous step. It's the same duct tape trick. 1 rubber band is all that's required. Do one first dry just to get the feel for the rubber band tension. Here are my 8 halves after removing the duct tape and rubber bands. A little bit of disc sanding is required to get these halves perfect. First, I touch up the bottom edge so that the half will slide smoothly on the table. Then I touch up the 2 glue surfaces. I know my surfaces are perfect when the lightest of sanding removes pencil marks from all 4 corners. As with all glue jobs, you've got to have real clean surfaces. Putting the halves together, especially in a small size like this, is relatively easy. Rubber bands, once again, become a very handy item. Get creative. Just find the right location, the right position, and you can clamp things like these together with rubber bands. If you don't think the rubber bands provide enough tension, try doing this dry and pull it apart. While that glue is drying, I'll get a jump start on the next part of the project. I need some MDF disc, and I need some waste barks to mount the bowls on. So I'm just doing a little bandsaw work here. These pieces of MDF will be mounted using a screw chuck, so I need a hole in the center. I'm turning cone-shaped tips onto these waste blocks. That will allow me to glue them into the bottom of the small end of the bowls. I need a 45-degree cone-shaped point on these blocks. These drilled holes will assist me in centering these bowls on the MDF plates. Screw chucks can be very handy. Mounting the MDF this way gives me the ability to take this back off and put it back on, keeping everything nice and centered. About 6 or 7 dabs of hot melt will hold this while I prepare the small end for the plugs. Here I'm just doing a little rough turning, getting rid of the glue squeeze out. A little diamond pointed scraper cleans up the small end so I can test fit my plugs. A burnish mark tells me where to remove more material. A little glue and the tailstock clamping pressure finishes the job. So here are my 4 bowls with their plugs all installed. I'll let these cure overnight before putting them on the lathe to turn. Next morning, here I am, truing up these plugs, putting a tenant so that I can mount these in a 4-jaw chuck. To remove the bowl, a little work with a parting tool gets most of the hot melt out of the way, and then just a little persuasion with this chisel takes it right off the MDF. Here are my 4 bowls ready for turning. It's my habit to put a mark on a waste block like this just in case I have to take it off and put it back on. I can use the same chuck job impressions. I'm starting the turning process at the top edge. I need a smooth flat top in order to measure the sidewall angle of 45 degrees. My next goal is to create a 45-degree slope angle on the side of the bowl. It takes a little effort to get this perfect, but that's what it has to be. You have to turn a little, check it frequently, and turn a little until you get a perfect 45-degree slope angle. I'm putting pencil marks about a ½ an inch in from each edge. These lines will guide me as I remove wood. I need the bowl to be thin in this area because later I'll be piercing it. I've created a template with about an 1/8 inch thick piece of purple heart there. That gives me a guide as to how much material to remove from the side of the wall. Before moving to the inside of the bowl, I'll finish sand the outside up to 400 grit. As I get to the finer grits, I'll do some power sanding. One last inspection and it's onto the inside. Because I plan on piercing the center area, I want it relatively thin, about 1/10 of an inch or less. So I'm trying to achieve a thickness of about 3/10, maybe a little stronger, on the outside rims. And as I said, that center portion I'm going to try to get down to about 1/10 of an inch. This is slow, meticulous work. It takes time. You have to go real slow and be real careful. An outside caliper works well for comparing the thickness of the 2 edges. I sanded the inside just as I did the outside, a combination of hand sanding and power sanding. Make sure you protect yourself from the dust. To remove the bowls from their waste blocks, it's a combination of an undercut on the inside and then a parting cut on the outside. Before cutting this apart, inspect your seams. If you find a bad one, well, that might just be the place to cut. By keeping a steady hand during the bandsaw cuts, it should only take a little bit of light sanding to perfect these surfaces as glue joints. I now have 8 half bowls. These are ready for the next step in this project. There's a lot of things you can do with half bowls turned at a 45 slope angle. Here's a spherical shape made out of 4 half bowls. I can take the same 4 halves and reassemble them into a different shape, kind of a inside-outside spherical shape. Or I can add 2 more for a total of 6 half bowls and get a different shape. There's really no end to this. The combinations are endless. But for this project, I also need some quarter bowls. So it's back over to the bandsaw to cut some half bowls into quarter bowls. By taping together the previously sanded ends, I can now go back to the disc sander and create a very good glue joint surface on those last cuts that I just made. So here are my 12 components, but figuring out how to put them together is another story. I've used the plastic model, and I've labeled everything the way it has to go together. This takes some time. It can get really confusing, but you have to have a model. You have to have everything labeled. There'll be a total of 12 joints to put together. Depending upon the configuration, rubber bands will work on some of these. On others, just hand-holding pressure for a few moments is about the easiest way to put them together. Here's another type of clamping system, but these particular bowl components are too small for these types of clamps to work. I've now consolidated my pieces down to 4 sections. Before proceeding, though, I think it's time to do some sanding while I still have good access. I have good access to some areas with my power sanding disc, but other areas will require a lot of fingertip sanding. This is slow, meticulous work. It requires a plan so that all the surfaces are perfected. Without a plan, it's easy to skip an area with one grit or another. In addition to using sanding discs, I also use an assortment of sanding mops, and a Dremel tool comes in handy. I've now sanded all my surfaces, and this is ready for the final glue job. I'll do these seams one at a time. Because of the shape, clamps are really impractical. Hand holding will work. The thickness of those outside edges allows me to hold this steady. Now it's a matter of cleaning up the last 2 glue seams. After doing that, it's on to the next phase of the project, the piercing. As I mentioned at the beginning of this lesson, this piece is to be a wedding gift for a very good friend. I'm going to pierce all the thin areas. I'm going to include the bride and groom's names, the actual wedding date, a few randomly spaced hearts, along with some snowflakes. The groom and I have a long history of benefiting from the slipperiness of snowflakes. This ribbon could be displayed many different ways. After looking at it from many different angles, I've decided I like this position the best. This is very slow work. I think I'll speed things up just a wee bit. This is essentially doodling. After I complete my main components, I'll surround all of this with random openings. A 400 grit sanding mop takes care of any fuzziness on the edges. This is the first of multiple coats of spray lacquer, and I'll hit it with the same sanding mop in between coats. The ribbon form, especially ones that are made from solid types of wood, provide a canvas for lots of different types of expression. Here's a few others that I've done over the years. This is just a bird's eye maple Mobius strip with ebony along the edges. And this next one is quite different, a spherical shape made out of 2 bowls, 4 half bowls. The staves were generated from Banksia pod material. This one, a tribute to John Lennon called Just Imagine. It's a trifoil knot with the pieces being made from canary wood. Here's another 6 half bowl style ribbon, lacewood with ebony on the edge. This one's quite different. It's called Mind Games. The piercing in the middle is good luck symbols. And one of my all-time favorites, an early Mobius ribbon called Mobius Sonata. This one is Tolerance. It's half bowls, half cylinders, half flat disc. All the religious symbols and cultural symbols are pierced through the center portion. This piece, called A Daily Gift, is quite different because the ribbons are concentric ribbons within each other. It's a little bit different technique. Now you're probably thinking that this kind of a ribbon that makes a complete circle with all those undulations is pretty complex, pretty difficult to calculate. Well, the truth is it's pretty simple. There are 16 components in each one of these 3 ribbons, 16 half bowls, actually almost cylinders, with a cone shape, a steep cone, if you will. And each one of those 16 half cone-shaped cylinders represents what would have been a flat segment. If you'd made a ring like this with flat segments, well, you know how to do the math there, and you'd create miter angles with an 11 1/4 degree miter in order to create a round ring with 16 large segments. Well, here it's just a little bit different. The slope angle on these cone-shaped cylinders matches this flat segment. So instead of like on the other ribbons that are normally, say, 45-degree slope, here we've got to have a slope that adds up to 360. So it's an 11 1/4 degree match to the flat segment. It's actually 90 degrees less 11 1/4 degrees in order to measure from the bottom here. 90 less 11 1/4 would be a slope angle, in this case, of 78 3/4 degrees. You use that information to calculate the miter angles on the staves. For the diameter, it's the same. The length of the segment determines the overall circumference, therefore the diameter. Here, the diameter of the cones determines the overall circumference, and likewise the diameter. It's the same concept of relationship between diameter, circumference, and pi. That's all there is to it. I probably shouldn't say this, but these ribbons just aren't that tough. Give it a try. You'll be amazed at how simple they really are. It does require that you minimize cumulative error during the cutting, construction, and turning steps. But with a little careful planning and some precise turning, it will come together and you'll amaze your friends. You'll have a lot of fun making these ribbon forms.